So in the third step, which is the threshold, you can see here we have probability of 1%, of 5%. If you can see here in the linear, we have the duration from the 0 duration into 150 hours, depending on your data actually, and the cumulative rainfall in the millimeter. And you see here the green one, it's based on the 1% probability, and 5% it will be more let's say more caution. And if you see the red and the green, sorry, here if we look to the highlights, this is the uncertainty related to, if you see here those numbers, yes, this is about the scale here, and sorry, this is the uncertainty, and here is also the uncertainty related to the scale and related to the shape. So in terms of the shape in here, okay, and this is you can see 0.07 plus minus. And about the intercept for scaling, you can see also we have 0.7 plus minus. So for you also later on, you will see that which results or where we will find less uncertainty in case of using deuce only, or in case of using just the CTRL, or when we integrated with the deuce. So in my case, in this article that we wrote, we found that when you use the deuce, those uncertainty get reduced. All right, and here in the result also, as we said, this is for the shape. Okay, so if you see here, this is the number of events. If we have like 170 points or landslides, you can see when the model use more points, it start the uncertainty get less. Okay, so also you can notice here when we use the deuce, the range of the uncertainty with the very small amount of data, it's less than the range that of using just CTRL. That's the point of using the deuce. It's reduced the uncertainty from the first time, from the first smallest group. But usually the software, the tool will check with adding more events until you get the maximum number of events that use. Let's say your data is just 170 points. But keep in mind, this tool also will discard, will eliminate or will ignore some of those points who doesn't have relative rainfall conditions. For example, it searched around those 15 kilometers around it and couldn't find any rainfall event during this landslide. So it will discard it. It will not consider as landslide. It will say maybe your data, you have an error in your data or something. But in the end, when you use all the data set, you will see that this is the reduction in the uncertainty. Then it will give you the curves of the relationship between the duration and the cumulative, and also it will give you more kind of test with the distance. So whenever you have all the data, you have here 15, you see 15 kilometer. So the default value for the CTRL is 15 kilometer. So you can see here within 15 kilometer, we still need all the data, you see, to be plotted. And more about the density with the number of the condition that we use. Also, it will plot for you the duration with the cumulative, the one that it's you can see it in here in the log. It will be plotted like this, and the probability based on the probability, which one is more confidence, we have more probable occurrence. This is about again about the cases that it will be plotted. Okay, so if you want to have a look for more of the results, now I will show you a summary. This is, for example, this is rain gauge 525. This is just one rain gauge, and you can see the amount of output that it come up from each rain gauge. So it will plot again the ED, and it will plot the rainfall based on the date with the rainfall amount, as you see here. So and it will plot also with consider the rainfall event. Do you remember in the first presentation we said we might have a gap? So either we consider this is one event, or we consider this all as one event. So here, when you consider it as all as one event, then you can take this landslide occurrence. You see here, this is the landslide occurrence date. This LIG is the name of the landslide. So this is the before landslides, how many hours you will consider. Okay, so all of this kind of test with the papers, you can understand all the process and all the assumptions. Also, it's clear here. So here, for example, it's consider the 126 hours. Here, consider only 30 hours before the landslide. Here, consider like almost 90 hours before the landslide. And here, consider almost 10 days before the landslide. You see 300. And different antecedents period. And you see here, this is the discredited rainfall conditions, DCR. So this is discredited, is not included, because also couldn't find a valid information related to it. So now let's have a look about each station. Again, the code will prepare also the data for you. So for each station, we just interested in the date and the record. Okay, so the code will prepare for you the data when you give the reading, for example, this sensor or this threshold, or sorry, this rainfall gauge number 90. You have, like as we said, 10 years of data. Once you give those separate files, or what we will do with the processing, the code also will carry some sort of processing that it will make the reading of the date in this way, year, month, day, and also consider the time, because this is hourly. Usually we have hourly data. This code work on the hourly data, as we mentioned. And here is the rainfall amount in this specific hours. For example, here it's all zeros in this time, but if you see here in the 23rd of January 1999, we start to have a small amount of rainfall within this hour. Okay, so the code will fetch for you everything and prepare your data in this nice way of presentation for all your items. Let's say this is what, how many you see here, we have 577 station, but what we saw in the table, this one, we saw just, we said 138. This is what came from Deuce, and this is all our data. So the code will just choose whatever available in here. It will match those station names with this station names in here and ignore the others. Okay, this is the benefit of using the Deuce. Otherwise, code will consider all of those points, all of those rain gauges. Now let's look at the result that it comes from the 3 steps. Now let's look at the results that come from the 3 steps, which we said the rainfall events, rainfall conditions, rainfall thresholds. it was in here. Yes, it was in here. So the reconstruction, this one, reconstruction of the rainfall events. This is the first step. What it does, it create for you the file that give you, for example, the station ID 572, all the rainfall events that have been within in this station for all the 10 years, for example. So it's a huge file. So you see, this is now all about 572, but then now it changed. Now it's considered another station, and so on. So it give you the reading. So you can see it's a huge file. If you want to check it, you can see now we are going to almost 72,000 row. Yes, because it's consider all our stations that we provide. So it give you an ID, it will give you the start of the events, the date of start, end of the date, and also the DE, cumulative, IE, maximum within 24 hours, all the information that you need from any rainfall event. This is the rainfall events in summary. Everything related to the rainfall event within specific rainfall gauge. And then it starts to reconstruct rainfall conditions. So the rainfall conditions, again, it give you the, firstly it give you the processing reports. Based on my data, I have 126 landslides, but the code couldn't find 26 landslides events, couldn't find any information about rain during this period, during this time of the occurrence. Couldn't find any information. All the stations that around the landslides couldn't give us any information that was a meaningful rainfall event that can cause landslides. So automatically the code discredited this landslide and just keep 100. It was valid. And here also it give you those IDs of the one that ignored landslide 26. It give you the ID. So you can take that and you can check it. You maybe the date of this it's wrong, so you might go and double check with the date of landslide code 2048. Go and check your locations, like based on here, this one. So let's say 20, LIG 0020. Let's come here to the 20. Yes, there is something wrong about this, especially maybe about the date or the time. In this date and in this time, there was no rainfall event, or there was one rainfall event, but this is not enough to produce landslide based on the criteria that we inserted. So you need to change, or you need to delete, or you need to find what's the problem about this date. Go and double check, go to the field, ask, take aerial photographs and see is it real data, this one, or there's some problem maybe one day before, one day after, maybe it happened in the night and they wrote for you 10th. It's not exactly the daytime. Okay, so there's very good indicator to give you what's the kind of problems that you have. And in here it give you all the landslides, okay, within the date of occurrence and how much rainfall it was during that time and within 24 hours or before. So it match those landslides with the rainfall events that we found in here. Okay, and it will try to create before we jump to this, this is the summary. Also one more result, it's about again every landslide and what is the readings about the rain gauges around it, the valid rain gauges. So here it talk about landslide ID 126. Landslide ID 126. This one. Landslide ID 126. It was in the 1999, and it's the 1st of August. So, according to this, they found that there is an event within the station of 555 started on the 30th of July in the time of 7 p.m. and ended at the 3rd day of August at the 11 p.m. which is our event. We said it's the 1st of August. So they could find like 1 day and 2 days after, they found one event. If you see here, this is our event, which is happened in the 1st of August. And they found one storm happened before, and the storms continue. So again, the code checked for you all of the event here, and give you the indicator about whether if we say that they consider the before, it took the 42 hours before, and try to find for you the information that might be useful to create threshold. Again, another station within, also close to this 126, code 586. This is station code. This station, it has also some record. It started on the 30th of July at the 11 p.m. and ended at the ended on the 9 p.m. on the 3rd of August. And it also showed you the readings and the amount of rainfall during this. So the tools work like this. It check all the stations that find within a specific. So here, how many stations? Found just 1, 2, 3, 4, and it's here. So this is the rainfall, the landslide location, and the buffer. If you can see the red area here, you see the line. So this is the buffer of 15 kilometers, and this is the valid stations around. This is all the stations, but this is only those stations that are valid, just those listed stations around. So you can see that why it's important to keep the dates in the similar format. Then the code will match the date inside the landslide file, and the dates within the rain gauge files, and the dates within the rainfall records. Everything should be set perfectly. Then it can give you the last, which is the landslide thresholds. So this is why you can see here, this is actually based on the probability. It's the important one for you. It's the last page. Now this is the threshold for all the study area using the 126 landslides and within the 138 rain gauges. And this is the threshold, and this is the log threshold with the specific uncertainty for the scale and the shape. And here is the uncertainty of the shape and the uncertainty of the scale also. So again, you can compare between using the deuce and without the deuce. If you see, this is now look much smaller here in terms of value. Well, this is the better one. But if the uncertainty keeping high, that's mean you should find the other way. But you tell me that you have one threshold for all the study area. I say yes, if you consider all the study area as homogeneous. Let's come to here, to the study area. Yes, because we have different regions. Actually, I keep this for you later when we talk about the endothermic plot. and about the if transportation map, maybe it's much better to open it for you. Yes, if you see here, we have one region, two regions, three regions having similar transportation or the aridity index also. So if you, in case you have too much data, then you can consider dividing the study area into 1, 2, 3, maybe 4. But for me, I consider it as 1 and 2, and I ignored it because I don't have landslides here. So I consider this area having similar condition of this area. I have to because I don't have enough points. So I consider this the north and the south almost having the similar characteristics. But in case you have a good amount of points here, consider this one study area, you will get one threshold. Consider this is the second study area, get one threshold. So you will have threshold for the north, threshold for the south. I think in the data that I have, I produced one for here and one for here. Anyway, we will see this during the course, and also you are free to do both or one of them, up to you. So so far, this is our summary about the results and about the tools. To recap, our flow charts will start with firstly data that you have, landslide inventory, and the rain gauge and the DEM. As you have, whatever you have, as simple as you have the data. Once you collect from the site, we will receive it from you and we start to prepare it. So here we don't have too many things to do in terms of data preparation. You just need the location, okay, and the projection. So make your landslide locations valid, rain gauge valid with and your raster with the elevation, and we'll start to optimize the amount of the rain gauges that you have. If you have 200, 300, we will try to apply 15 kilometers from the landslides. After that, we search within watershed if we can find something, or within slope unit, or within the elevation. After we get this, we reduce the amount of the rain gauges from the 200 you have, maybe we become 150. Or if we couldn't find, we will use them as it is. If you don't have too many landslides, too many rainfall gauges, there is nothing to do. You just need to use them directly here. When you come here, you start to process firstly your data, clean them, prepare it based on the dates, formats, and make sure there is no missing data. Also for the landslides. Then we check the parameters based on the starting the season, ending the season, which area that you need to consider alone, or which data that you need to, which study area if you want to separate it, based on the aridity index, as we mentioned, and how many hours that you need to consider your event. This is all parameters we need to input, and then the code will work automatically to produce what we mentioned. So if you are ready, you have your data, bring it along, and let's begin on the next session to work on the Deuce model.